Hi, I'm Ms. Van Loan, and in this video, we're going to complete Module 3, Lesson 4, Independent Practice. Remember, I recommend using your math notebook and using your paper the normal way, which is called portrait. Please use a pencil, either number 2 or mechanical, and have an eraser handy. For the purposes of this video, I will be using a blank sheet of white paper, and it will be in the landscape orientation. That is because it works better for the video camera. I'm also going to be using pen because it shows up better on camera. All right, let's get started. Module 3, Lesson 4, Independent Practice. Put your name. And before we begin, I want to talk about something really important, just in case you're skipping the lessons and just going straight to this. We're going to be solving equations a lot like we did in Module 3, Lesson 3, except now we're going to have inequality signs. Something like this. Remember, 5 is greater than 2, and maybe 5 minus 8 is going to be less than 2, and things like that. So we've got some inequalities, and we'll have to do a little bit of solving here. So this would be -3 is less than 2. That's true. And I want to point out something. If you're going to multiply or divide by a -1, you are going to have to switch the sign. So watch this. If I multiply this side by -1, I'll put my double line here, kind of like solving equations, and I'm going to multiply this side by -1. What I wind up with is a +3, and 2 times -1 is -2. So if I keep the inequality with the small side pointed to the 3, that would say that 3 is less than -2. Is that true? No, 3 is bigger than -2. So just like in our little example here, anytime you multiply or divide by a negative, we have to flip the inequality sign. So I just wanted to point that out because that's so important, and it's something students often forget. So anytime you multiply or divide by a negative, flip the sign. Specifically the inequality sign, but we're just going to try and write that in as short of words as possible, as few of words as possible. All right, let's do number 1. Let's get going. Number 1 says, what is a solution set? And remember, I do want you to write down the question. You don't have to write down the whole question. We could have just put what is a sol set for solution set, but I do want you to write down the question, especially when it's just an equation. Please always write down the question, show the steps to solve, and then box the final answer. So what is a solution set? Well, when we're talking about equations and inequalities, it's any possible answer. So it's the list of all the possible answers. So when working with equations and inequalities, it's a list of all possible solutions. And you might be saying, but Ms. Van Loan, when we're solving an equation, we just get one number. So how can we say that it's all the possible solutions? And I'm here to tell you, oh ho ho ho, equations get a little more complicated than that. And when you are finding the solution to equations, sometimes you will get more than one answer. And you might be thinking, but how and why? Well, I'll show you how and why. Let's say, for example, that you have an x squared somewhere in your equation or maybe in your inequality. Well, if you're going to try and find the solution to an x squared problem, like 36, and you need to unsquare it or find the square root of 36, you could have negative 6 times 6, or you could have 6 times 6. So now we're getting two possible solutions for the square root of a number. And that, my friends, is how we wind up with more than one answer for an equation. That would look something like this. Maybe x squared equals 36, so we square root both sides, and then we could get either negative 6 or 6 as the answer. Number 2. Solve 2x is less than 8. So let's use a highlighter here, because putting the double equal sign doesn't really make sense because it's not equal. We're doing an inequality here. But we're going to follow the same steps. So if you imagine, or if I'll show you real quick, (2x) is equal to 8, in this case less than, 2x is less than 8, and we divide by 2, right? We're going to divide it into two groups, still following that same procedure, then x is less than 4. So we're following the same procedure, divide into two groups. We did not multiply or divide by a negative, so the sign stays the same direction, and we have x is less than 4. So if we want to graph that, put a 0, 1, 2, 3, 4, here's 4, and it's not less than or equal to, it's just less than, so we'll do an open circle on 4, and we'll shade in less than 4, because x, the solution set here, is anything less than 4. It could be 3.99, it could be 3.5, it could be negative 587. All we know is that x is less than 4. And so on a number diagram, it would look like that. Let's do number 3. X minus 15 is less than or equal to 9. Let's separate the two sides of our inequality. And we'll take this negative 15 and flip it, plus 15 on this side. So now x is less than or equal to, remember we didn't divide or multiply by a negative, 9 plus 15 is 24. So again, if we wanted to do a little diagram here, we'll just estimate. We're going to say 24 is about there. Sounds good. Since it has the equal sign on it, so it's less than or equal to 24, we're going to include 24. We bubble in the circle, and then we shade less than. So the solution set for this one is all numbers 24 or less. So x is all numbers 24 or less. This is how we draw it, and this is how we say it. X is less than or equal to 24. I think I can fit 4 on here. 4. 14 plus x is greater than 3. So I've got my two sides of my equation mat, right? Picture those algebra tiles. And we're going to take the 14 and flip it to the other side, which means now it's negative 14. So 3 minus 14, or if we have negative 14, and we're going to take 3 from that and cancel it out with those 3. Here, let me show you. All right, 14 plus x is equal to 3, or x plus 14 equals 3. So let's flip. Now I have x and 10, 11, 12, 13, 14 negatives. and 3 positives. So I can take 3 negatives, cancel them out with the 3 positives, and I have x and 11. X and negative 11. And we didn't divide or multiply by a negative, we just flipped. In other words, we subtracted 14 here and subtracted 14 here, those canceled out. We left negative 11. The sign stays the same, so x is greater than negative 11. If we draw that out, we'll have a number line. We'll have negative 11. We'll have an open circle because it does not include negative 11, it's just greater than, and then we shade positive. Let's do number 5. X divided by negative 4 is less than 7. Ooh, we get to have a negative, and it's being divided, so we'll multiply, meaning this is going to flip. Very exciting. We finally get that example. So if we're dividing by negative 4, to cancel that out, we need to multiply by negative 4. Multiply by negative 4 on both sides. So that cancels. And we have x, and 7 times negative 4. 7 times 4 is 28, and it's negative, and the sign here is going to flip. So x is greater than negative 28. And if we draw that, we'll put a 0, we'll have negative 28. We'll have an open circle because it does not include, there's no or equals, it's just greater than. And then we shade greater than. Number 6. X divided by 5 is greater than negative 4. So we're going to follow the same process here, but we're going to multiply by a positive 5. So times 5 times 5. That cancels. X is greater than, because we multiplied by a positive 5, not a negative. X is greater than, so 4 times 5 is 20, and that's negative. The negative 4 was already over here. So that negative doesn't make this switch. We're looking at this number right here. Is this number that we're multiplying on both sides, is it a positive or negative? It's a positive, so the sign stays the same. And if we draw this out, we'll have a 0, negative 20, open circle, and shade positive, shade going above because it's greater than negative 20. Let's do number 7. Negative 4x is greater than or equal to 24. So we have 4 sets of x, and it's negative. We're going to divide it by 4. Divide it by 4. And since this is negative, we're going to divide by negative 4. We got to do it to both sides. Divide by negative 4. So the negative 4 is canceled, and we're just left with x. And since it's negative, we're going to flip. So flip the direction. X was greater than, but now x is going to be less than. 24 divided by negative 4. So 24 divided by 4 is 6, and then put the negative sign on there. X is less than or equal to negative 6. Let's draw that. We'll put a 0, negative 6, and we're going to fill the circle in on negative 6 because the or equals to means it includes negative 6. And we're going negative, we're going less than. So all the numbers less than negative 6, including negative 6. Number 8. X plus negative 17 is greater than 28. So let's take our negative 17 and flip it to the other side. We're not multiplying or dividing, we're just flipping, or in other words, we're going to add positive 17. 8 plus 7 is 15. 2, 3, 4. So now we have 45 on that side. And the x is all that's left on this side. So picture it on the equation mat, right? We've got an x and negative 17 tiles. We flipped the negative 17 over here to be positive. We added all those up, counted them. And so we have an x over here and 45 ones over here. We didn't divide or multiply by a negative, so that stays the same direction. X is greater than 45. Put a 0, put a 45. It does not include, so it's an open circle, and then x is greater, so we shade this direction. Number 9. Ava is purchasing a new washer and dryer. She has a total of $950 budgeted for this expense. The washing machine she is purchasing costs $485. Write and solve an inequality to find out how much she can spend on the dryer. So $950 is going to be the maximum she can spend. So she has to spend $950 or less. So the maximum she can spend. So that means that whatever we're spending here is going to have to be less than 950. So we're going to put the less than over here. We could write it the other way. So whatever she spends is going to have to be less than or equal to $950. Okay, so what is she spending? So she's going to spend $485. That's what she already is spending on the washing machine, and then plus the dryer. So we'll say X for the dryer. So the washing machine plus the dryer is going to have to be less than or equal to $950 total. Because she doesn't have to spend the full amount. She could spend less, right? So if she spent about $200, then 200 plus 485 would be 685. And then she'd save money and she could go spend that money on something else. But she could totally max out her budget and spend the full $950. So let's solve this and we'll find out exactly what the maximum amount she can spend is. So we'll solve it the same way. We're going to take 485 and we're going to flip it to the other side. In other words, we're subtracting 485 here, and when we flip it, we have negative 485. We took it away from there and flipped it here, so now it's negative over here because it was positive. Remember, we're not multiplying or dividing by a negative, we're just flipping that over. So now x is still less than or equal to whatever this subtracts to. So I'm going to have to borrow so she can spend a maximum of $465. So x has to be less than or equal to $465. So the dryer must cost less than or equal to 465. Less than or equal to 465. All right, let's see if I can, oh, and it also wanted the equation up here, so let's write that. 485 plus X was less than or equal to 950. It's a little bit neater than up there. And I think I can fit number 10. Nico is planning to make treat bags for everyone in his class. He has 92 pieces of candy and wants to make sure everyone gets the same amount to be fair. There are 23 students in his class. Write and solve an inequality to determine the number of pieces he can give each student. So this is like saying on our equation mat, we've got 23 students on one side and 92 pieces of candy on the other side. How much does each kid get, right? So let's do that. We'll have X will represent the students, and we'll have 92 pieces of candy on the other side. Oh, and it's 23 students. So it's going to be a maximum of 92. So the number of candies that they get will have to be less than or equal to 92. So the students will each get less than or equal to some amount. We're going to figure it out. So let's divide by 23. (92) divided by 23. Well, 23 is kind of close to 20, and 20 times 4 is 80. So let's see if 4 will work. 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. Oh, that that worked out perfectly. So 92 divided by 23 is 4. And we divided by a positive, not a negative, so this stays the same. And then we just have X. So one student will get 4 candies maximum. So each student can get 4 candies maximum based on him having 92 candies total and 23 students in the class. So each student can have a maximum of 4 candies. And I know I said that different than over here. I said a maximum. We could have said each student can have less than or equal to 4 candies, but that would take more writing. If you just say a maximum, that is the same thing as saying less than or equal to. Because look, when we draw it out, we've got X, we've got 4. The maximum is going to be 4 because it includes 4, and then we're going to shade less. Should I shade into the negative? So we're talking about reality here. I actually shouldn't shade into the negative on number 10 or on number 9 because we're not going to include negative values. It would actually be, the solution set would actually be 0 to 4 candies. And it's not going to include any fractional candies. Whereas number 9, it could include fractional because we call them decimal, because it can include change. So I want you to kind of think about how would you put that on a number line. I kind of showed you here. Some things to think about if you want to continue thinking about these problems. How when we're talking about reality, we might have to cut off our solution set because the kids are not going to turn around and have negative candies and owe the teacher candies. That doesn't really make sense. All right, I hope you guys have a great day and enjoy thinking about these problems a little more.